It was 3 in the morning on a rainy Sunday in Santa Clara when an internal email hit the inboxes of 7 top executives at the world's most dominant chip maker. The subject line contained no warning. Just a single attachment labeled with a raw performance file. Inside that attachment was a benchmark test, a stress test run on an artificial intelligence accelerator that legally, physically, was never supposed to exist. The engineers who compiled the data thought it was a software glitch, or perhaps a clever hoax designed to rattle the stock market before trading opened in New York. But as the senior architects scrambled into an emergency video conference, reviewing line after line of real-time telemetry, the room fell dead silent. The chip had not only processed massive neural networks at peak capacity, it had done so using an architecture that completely bypassed every major patent held by Silicon Valley. The tech titan that had built a multi-trillion-dollar moat around global computing was staring at a phantom rival. And the scariest part wasn't just that the silicon worked. It was the realization that the blueprints had been developed inside an engineering lab everyone thought was dead. To understand how a corporate nightmare of this scale unfolded, you have to go back to the moment the supply chains were sliced in half. It was a cold strategy executed in broad daylight, a series of sweeping trade restrictions designed to cut off an entire foreign economy from high-end semiconductors. The calculation in Washington and California was clean and ruthless. Without access to advanced lithography, the rival nation's tech sector would freeze in place. For the first 12 months, the strategy looked like an absolute masterstroke. Quarterly filings from the leading foreign tech firms showed devastating drops in hardware deployment, enterprise server rollouts stalled, and key research teams were quietly dissolved. Wall Street analysts declared the race over, crowning a single Silicon Valley firm as the undisputed sovereign of the artificial intelligence era. Inside executive suites, the mood was triumphant, margins soared, orders backed up for years, and world leaders lined up to secure allocations of the world's most valuable silicon. But while the market was celebrating total dominance, something invisible was happening beneath the surface of the corporate registry. Deep inside a network of seemingly unrelated holding companies, a quiet restructuring was taking place. Engineers who had been laid off from restricted tech giants weren't leaving the industry. They were being quietly hired by nondescript research institutes backed by endless state capital. These teams weren't trying to buy Western equipment anymore. They were tasked with a far more dangerous assignment. Assume the Western supply chain will never open again, and build a completely parallel pipeline from scratch. The initial years were plagued by internal friction, massive budget burn, and embarrassing hardware failures. Early prototypes melted under basic computational loads, while software compilers failed to translate simple instructions into execution. Leaked reports from inside these foreign labs reached Western intelligence circles, describing a chaotic, fragmented attempt to rebuild decades of microchip history in a matter of months. Executives in Santa Clara read those reports and smiled, confident that physical chemistry and photolithography couldn't be rushed by executive decree. What they failed to realize was that desperation forces a radical shift in corporate strategy. When you cannot buy the most advanced manufacturing tools on Earth, you are forced to stop relying on brute physical miniaturization. You have to make the software smarter, the interconnects faster, and the system architecture far more efficient than anything the market has seen before. And that is precisely where the secret breakthrough took place. Instead of trying to copy the physical layout of Western accelerators, a rogue group of system architects decided to rethink how data moves between memory and logic. In traditional high-end chips, massive amounts of energy are wasted just pushing information back and forth across tiny copper bridges. The foreign team abandoned standard design rules entirely, stacking memory layers directly on top of processing cores using an unproven, highly volatile packaging technique. Industry veterans had tested this exact method years earlier and discarded it as too risky for mass commercial production. Yield rates were low, manufacturing costs were unpredictable, and thermal management was an absolute nightmare. But when you are under total trade blockade, financial risk ceases to be a limiting factor. The state-backed labs poured billions into solving the yield problem, burning through thousands of test wafers until the process finally stabilized. By the time Western analysts realized what was happening, the foreign firm had quietly built a fully functional packaging line right under the nose of global compliance officers. If you're finding this deep dive into corporate warfare and technological geopolitics fascinating, make sure to hit that subscribe button right now so you never miss an insider story. Back in Santa Clara, the true scale of the threat didn't hit until a physical unit was acquired through a third-party distributor in the Middle East. A special task force of failure analysis engineers was assembled inside a cleanroom. Tasked with taking the mystery processor apart layer by layer, they used focused ion beams to slice through the silicon, mapping the internal circuits with microscopic precision. What they expected to find was a crude assembly of old tech, cobbled together with black market components. What they actually saw under the electron microscope left the engineering lead speechless. The chip didn't use a single component that violated export controls, yet its throughput rivaled flagship Western hardware. It was a masterclass in architectural evasion. A system designed explicitly to turn legacy manufacturing equipment into a high-throughput engine. The foreign rival hadn't just caught up, they had created a totally foreign branch of computing history. And then, the second shockwave hit the corporate boardrooms. It wasn't just that the chip existed, it was the pricing structure attached to its international distribution, because the entire development cycle had been subsidized by national security funds. The foreign firm could afford to sell these units at a fraction of Western prices. For years, Western tech giants enjoyed gross margins exceeding 80% on AI hardware, treating their silicon like precious metals. Suddenly, enterprise clients across Asia, South America, and the Middle East were presented with a viable alternative that cost 60% less. Quiet inquiries began flooding into regional sales offices, asking if software stacks could be ported to the new non-Western standard. The monopoly's pricing power, the single source of its unprecedented market valuation, was suddenly under direct assault. Panic spread through internal corporate communications. As executives realized the trade bans had backfired in the most catastrophic way possible, by locking a fierce competitor out of the global market, they hadn't destroyed them. They had forced them to create an independent, self-sustaining ecosystem, an ecosystem that was now immune to sanctions, immune to export controls, and hungry for global market share. Inside Silicon Valley boardrooms, the strategic discussions have shifted from offense to pure defense. Lawyers are reviewing patent portfolios, searching for any legal leverage to block the distribution of the new silicon in neutral markets. Engineers are being pushed to accelerate next-generation roadmaps, burning through executive budgets to widen the performance gap before the rival's second-generation chip hits the market. But the momentum has undeniably shifted. The foreign manufacturer is already building massive new fabrication facilities, funded by guaranteed state contracts and eager enterprise buyers across the developing world. Every single unit they ship breaks the Western software lock-in a little bit more, training a new generation of global developers to write code for a non-Western architecture. We are witnessing the end of the single monopoly era in high-performance computing and the beginning of a Cold War in silicon, a war where market share won't be won by press releases or stock buybacks, but by who can manufacture computational power at scale under severe geopolitical pressure. The giant in Santa Clara is still the richest tech company on Earth, but for the first time in a decade, its executives are sleeping with one eye open because they know that somewhere in a quiet lab across the Pacific, lights are on, machines are humming, and the next batch of mystery chips is already rolling off the line. The only question left for Silicon Valley is simple, yet terrifying. Did the sanctions preserve American technological supremacy, or did they just unleash the one competitor capable of tearing it down? If you want to stay ahead of the hidden corporate battles shaping our technological